Hello everyone. So in this video we are supposed to see the continuity of the previous video where we were talking about I'm sorry guys, taking an analog input, okay, using an analog pin. So let's say taking analog input of, let's say, a in the pin of A0 or in the pin of A1, any pin you want, you can take an input, and when you take that input, that can change from 0 to 1023. And since we have to give an analog output, respective analog output of that input, that is changing from 0 to 255. So we have to do a conversion of the range related conversion, okay. A particular value that is in the range of 0 to 1023 now should come, okay, in the range of 0 to 255. So it takes a lot of time to draw with this paint, so I'm avoiding it, okay. Just see this, okay. So the input value that is in the 0 to 1023 should be given in the output value in the range of 0 to 255. So we have to do a conversion, and we have to take that converted new value, okay, the range wise converted new value, and we have to give it as an output as a LED pin, maybe pin number 7, analog output. This is all we have to do, okay. So in the last video I talked why we should do such a conversion, what is the need. So you can go and watch that, right? So it is so obvious, excuse me guys, okay. That's fine. So for a simple calculation, let's say you see a simple thing, you analog input, okay. So how we are planning to give that analog input? Through this variable resistor, okay. So we will have this variable resistor, plus 5 one side, let's say plus 5 is this, okay, and the other side is ground, let's say this is ground, and we take this input to, let's say, A0 or A1 or any pin, okay, A0, let's say A0. So then what we will do, we will have the Arduino board or whatever, okay. So I will make it a big so that it's easy to draw something. We will have a Arduino board. So this is the A0 pin, and then again from pin number 7 we will have a resistor and an LED, right? So you know all these things, right? And the other side should go to ground, okay. So this is the circuit, simply talking, okay. We will do a demo circuit, don't worry, in the simulation environment. For just to get some idea for the moment, I drew this drawing, okay. So this is very crude drawing, just ignore it. And from what you have studied up to now, if you have followed my tutorials up to now, I don't have to even draw this diagram, because you know how the circuit is going to be, okay, from the experience, okay, cool. So now where did we leave? Okay, here. So we have to do a conversion, right? So simply talking, if you have an analog input is 1023, what is the respective value we are supposed to give in the LED pin, okay, that means analog output. Can anybody give an opinion? So we know we are in the maximum range in the analog input. So in the analog output also we should give the maximum range, okay. So if the input is 1023, the output should be 255 undoubtedly, okay. Or in other words, for 5 voltage only the analog input is 1023. So if 5 voltage is coming in the analog input, the analog output also we have to give the 5 voltage, but according to the output scale, 5 voltage is 255. You understand? So anyway, if you understand it, that's fine, you can think of any way, okay, this scaling scenario. So if it is 1023 in the analog input, the output will be 255, it's undoubtedly. If it is I'm sorry guys, let's say the half, what is the half value? 1024 by 2, 512, so minus 1 is 511, okay. So you know these things from the previous analog input videos. If you don't understand it, you have to watch the videos, watch them. So this LED output, okay, A out is, I'm sorry, so this is the half of the 1023, okay. So what does it mean? We are here. So in the input we are giving half, that means 2.5 voltage is coming. So in the output we have to give the particular voltage, 2.5 voltage. So in the output also we have to give the half of the output, because our scale is again 0 to 5 voltage, but 255 scale units, 0 to 255. So again I have to give the half. So what is the half of 256? 128, and I have to do a -1 because I am starting from 0, so the respective value will be 127. Don't worry if you don't understand this. You should understand this. If you don't understand this, still don't worry. Okay, so 511 should be 127 here. Okay, so if you are getting confused, only you are getting confused with the -1 scenario. Okay, just don't worry. That's fine. So what we are supposed to do is, okay, now let's say this is something we are doing manually, right, with our common sense, and also we can come up with an equation and we can calculate them, right? But if there is another better way to do this, okay, is there anything? There is a way, right? So how you can do a conversion, we have studied about this, right? Range based conversion. How to do it? We have the map function. Okay, so we take the map function. Okay, we will take the map function and we pass the values, right? So how to pass the value? First is whatever this input analog value x, and then the initial range from lowest value to highest value. So what is our initial range? 0 to 1023. The lowest value is 0, highest value is 1023. Okay, so 0 comma 1023. Okay, then what we should do? This is our initial range, that means the input range. That input range should be converted to the output range. So then what we have to do is the current or latest or output or this needed range. What is the upcoming range? Okay, so we know what is the upcoming range from 0 to 255. So we have to pass the lowest value and highest value. So this is 0, 255. Okay, so now you will understand why I was teaching you the map function, right? This is a very important thing. Okay, this map function will do every calculation, whatever the input value you are passing, the analog input value. So the analog input value should be passed here. Okay, whatever you are passing, that will be converted. Okay, this the map function will return the converted value, converted new range value, right, for output, for giving the particular analog output for this respective input. That means for this 0 to 1023 range, 0 to 1023 range, 0 to 1023 range, if you are giving an input value, that respective value for this input value in regard to the output range 255 will be obtained through this map function. Okay, so if you are giving 511, the map function should return you somewhere nearly at least 127. Okay, so if you are giving 1023, map function should give you 255. Okay, so any range value you can give and as an input and you can see it. Okay, so your analog and input value should go here, and then these are fixed values, so you don't have to worry. So this is a new value that you should pass as the analog output value, that means the analog write value. Okay, so this converted value should be passed to the LED as an analog write. Okay, so I can simply say, okay, this should be like this. Okay, analog write whatever your LED pin, comma, your new converted value. So let's have this value as x, let's say. Okay, let's have it y. Okay, so the y value should be passed to the analog output. So what is x value? X value is the analog input value. So we can have is x is equal to analog read. Okay, let's say A0. Okay, so A0 value is being read and the conversion is happening here, and the new value is, that means y converted value is passing to the analog output. So now we are good. Now if we are giving 1023 as an input, that means the maximum rotation of the analog input, the output will be 255. That means the maximum value of this analog output. Okay, so just don't worry, try to catch that flow what I was talking about, and we will do the coding implementation and proper clear explanation, further explanation in the upcoming video, guys. Okay, so until then, consider subscribing us and have a great day ahead. Stay safe, guys.